You all see this?
Yes.
All right. So today we will get started with version control system. Before going to that, let me show you what we discussed yesterday. Like yesterday, we have an intro or the demo where we have got a big picture or a high level picture of what is DevOps, why DevOps came in. And this is the CI/CD pipeline we were just having a look at yesterday, right? And like I mentioned yesterday, there were different tools integrated, and that's how we formed the CI/CD pipeline or the tool chain. So here in this pipeline, the first tool is Git, right? So we'll be zooming into each tool, understand it thoroughly from basics till advanced concepts, and then get into the pipeline. So step by step, we'll build the pipeline by learning the tools. So today we will get started with Git. We will learn Git from basics and complete all the real scenarios with Git, and then we'll integrate it with Git. So today we are going to start with our first tool in the DevOps, which is Git version control system. So let us first understand what is a version control system. Why do we need a version control system? And then we'll begin with this. So let me talk about why or else what is a version control system. To understand this, let us take a simple scenario. Let us assume there is a project and all the project work is kept on some shared folder. I'm talking about a scenario where version control system is not used. Okay, let's assume there is a shared folder where all the project files are managed. Here are all the project files and the team connects to this shared folder and use the files. So let us assume there are two people, two persons, person A and person B. Both of them got this file too into their local computer and working on it. So after day one, person A kept his file back after day one. After day two, person B kept this file back. Again, I'm telling you, this is all a scenario without version control system, without using version control system. So, okay, fine. Both of them have downloaded the file, made the changes and kept the file back. So after after day two, this file two will have which person changes? Will it have both person changes or which person changes will be there on file two after day two?
Day 2. File 2. File 2, day 2.
Which person changes will be there on file two? Either person
B.
or person B changes. Person B changes will be there, obviously, right? Because what is happening here? Person B is overwriting the changes of A, right? Person B is overwriting changes of A. Only person B changes will be there, correct? Isn't it? So B doesn't know that he is doing it. Even A doesn't know that his changes are being overwritten. So this is happening without each person knowing it, without each person knowing this, right? So if this keep on continuing, assume this is a team of 10 people. If this keep on continuing, the project goes messed up. The project gets corrupted, right? Also, these people have to concentrate on the client requirements or the changes they were making and all. They cannot focus on whether their changes are being stored properly or not, their changes are secure or not. Correct? So how to achieve this? How can we allow multiple people working on the same file? So there could be multiple people because it's a team of people, multiple people working on the same file. So how can we allow this without being overwritten, without being changes messed up? So that's where version control system. That's one of the use cases where version control systems comes in, right? So this is a system which will not allow changes being overwritten or changes being ignored. So it will take care of the changes and see that the changes are properly saved, secured. How and all we are going to see with the hands-on with the labs. So that's one of the use cases. And next use case is, let's suppose, okay, application is working fine till 7 o'clock today. Something went wrong and application was down by 7:15. We want to immediately revert the changes happened during this time and bring the application back. So how do you know, like, how can you quickly bring the changes or revert the changes or undo the changes which happened during this period? You need a system which can provide that kind of detailed logging, right? Like you need a system which can provide detailed logging, including, okay, it's a file to person B made the changes on line number 8 at 7:5, which led to the application crash or application down. Also, so that we can identify this and we could like undo those changes and bring the application back without impacting the business, right? So we need a system which can provide detailed logging like this, including the file name, person name, and the changes where this person made the changes. Right? Again, this is not human possible. We need a system which can handle this. That's where version control systems comes in. Right, that's another use case. And the third use case is, let's suppose, okay, user is working with, let's say person A is working with a version A. Client came with new requirements and asked to make a version 2 of this file 2. What this person did, he has overwritten this file or deleted this file and made a new file and made a version 2. Okay, fine. But after 10 days, client came back saying that we need an older version. We need the previous version. So again, a rework, right? You have to rework and bring the old changes back. To avoid this, better maintain the versions, maintain the backups. Don't ever delete the old files. Maintain the backups or maintain the versions, again, which is possible through version control system. So these are some of the use cases where version control systems comes into picture. And who will use it? Obviously, it's a life for developers. It's mandatory for them, right? So developers use it. Nowadays, now not nowadays, we have automation testing from since long. So even testers do write test cases, automation test scripts, even they have to use this to maintain their files. Even ops teams use this. They have config files, configuration scripts, automation scripts and all. Even they use it. Obviously, DevOps persons use it. They have manifest files, configuration files, playbooks, and so on. So everyone or anyone in IT should learn it, is what I would suggest, because it is such an important tool. It will help to manage your files. It need not necessarily be only program files or coding files. It could be any script files, even any documents, any text files also can be version controlled. Basically, any static files can be version controlled. Right? So everyone should learn it. And why are we learning it? And what is the perspective we are learning version control system here? Here we will be learning version control system in two perspectives. First, to manage our files like anyone, like how do you version control? How do you have backup? How do multiple people work on the same file? So we will learn first Git with respect to managing our project, managing our files. Next, we'll learn Git with respect to the pipelines, like how do you integrate it? Okay, developer have written their code and kept in their version control system. How do you pull that and create the CI/CD pipeline? So this is another perspective of learning it. We will cover both. First, we'll get started with managing our files with a version control system. Then we will learn with respect to integrating it in the pipeline. Am I clear? Any questions in this part? Are we clear here?
Clear, clear.
Right. So that is what a version control system is. And depending on their architecture, they were categorized as centralized version control systems and distributed version control systems. So here is the centralized architecture. Like this is the central server or the remote server. And these are the workstations of individual developers or collaborators. Like, or else if it's a DevOps team, DevOps engineers, or if it's a testing team, it's a testers, whoever it is. So these are the workstations of individual collaborators. So they will connect to the remote server, get the changes into their local, make the changes here and put the changes back. As simple as that. This is how centralized version control system works. And what are the challenges or drawbacks of this? The challenges being central or remote server, let's say. Okay, you are making changes to the central or remote server. So whenever you make changes to the central or remote server, or else to work with this, to get the changes from the central or remote server and to work with this, you need to have network connectivity, right? Definitely network connection should be there. Let's suppose, okay, networks are disconnected. Entire work is halted. You cannot connect to the remote server. That's one of the drawbacks. Second thing is, let's suppose for some reasons this central server is crashed or lost. Chances of recovery are very less because it works like a single source of truth. Right? Is this much clear for all of you? Are we good?
Yes.
And then comes the distributed version control system. Distributed version control systems are like, okay, this is the workstation of individual user, right? And this is the remote server or the central server. This is remote or central server. And this is the workstation of individual user. And if you see, every user or every collaborator will have another repository, which is called as local repository. This is called as local repository, which is a copy of the remote repository. Every user will have a copy of it. So again, they will not directly work on this local repository. Rather, they'll work on another directory or a folder, which is called working copy or working directory. They'll make the changes here, then push to local repository. From local, they'll push to remote. That's how changes goes to remote. It's like a 3 steps before your changes goes to remote. From local, it goes to, from working directory, it goes to local repository. From local repository, it goes to remote repository. And here, if you see, let's suppose, again, to push to remote repository, to let's suppose, okay, you want to move your changes to remote, or you want to get a copy and create a local. For these things, yes, you need a network connectivity. Let's suppose, okay, network connectivity is not there, network disconnected. You can still continue working on local. Local is nothing but this is your own local computer, your own workstation. So you can still continue working on local. Only to push the changes or to pull the changes from remote, you need network connectivity. Means work is not halted. You still continue working on local, and also these commands to push and pull to remote are less frequent because only once complete work is done, we'll push or we'll get a copy. It's not very frequent. Most of the times, majority of the times we work on local, which is like accessing the hard disk. So network connectivity is not required. It's needed only to push or pull, which are less frequent. And also because majority of the times you have to access your hard disk, it was quite faster, right? And also, let's suppose, okay, the central server is crashed for some reasons. There are developers or DevOps engineers who have a copy of the remote repository, which is local. So chances of recovery are also more, right? So these are the things we have, like network connectivity, it was faster, chance of recovery are less. So these are the advantages of distributed version control systems. And distributed version control systems, particularly Git falls under this architecture. Git is a tool which uses distributed architecture, and Git is the one which is very widely used, particularly in modern DevOps projects. Am I clear? Are we good? Any questions in this architecture?
No, ma'am, it's
You
clear.
can free to respond. If you are clear, appreciate your quick responses. If you still have any questions, you can feel free to ask. That's how you learn.
It's clear, ma'am. Clear.
Right. Thank you. So let me give examples of few tools which falls under each category. Like we were talking about centralized version control system architecture and distributed version control systems. So under distributed, we have Git, Mercurial, Fossils, falls under distributed, right? And what are centralized version control systems? TFS, SVN, These are some of the tools under centralized version control system architecture. Like I said, Git is very widely used in the modern DevOps approach because of this distributed nature and the advantages it has got. So and that's how the tools are categorized. Now that we learned the distributed architecture in general, let us deep dive into the architecture of Git. And Git is very widely used in the real world. If you know Git, you can work with any other tools very easily. They follow the same analogy and the concepts would be similar. Terminology may be different. But if you expertise one tool, that's it. You can work on any other version control systems, and that's what is expected from the interviewers. So let us get started, deep dive into the Git. And also, here is the Google Trend reports of Git when compared with other tools like SV and TFS. This is a graph from 2020. You can also get the latest graph. You will still see the same. You can see that blue graph is for Git. Other tools you can see they are not at all unequal competitors to Git. Can you see that? So,
Yes.
So that's how Git is very widely used. Now let us get into the architecture of Git. Listen here carefully. Whenever we are doing hands-on, whenever we get started with the lab or doing any commands, anything with Git, this architectural diagram should be there at the back of your mind. So let us understand this thoroughly. Like we were talking about, right? This is my workstation. Let's assume, okay, I'm a DevOps engineer. This is my workstation. And this is the remote repository. Like we learned, right? There'll be two repositories, remote repository. You copy from remote and create this local repository. Correct. And also, like we discussed, there'll be a working copy, another folder where you actually make changes to the files, right? So these are the things. Now, okay, I made some changes in some folder called working directory. How your changes goes in? After making changes, I should move them to something called staging area. Staging area is also called as index area. It's a virtual layer. Okay, let me write here. It's an index area. It is also called as virtual layer. It's a virtual layer. It's not a physical folder. It's just a virtual layer. So you move your changes to staging. From staging, you move your changes to local repository. From local repository, you will move your changes to remote repository. Means it's like a 3 steps before your changes goes to remote. This is called Git tree or Git architecture. This is not possible. This is not possible. Like from working directory directly pushing here, or from working directly pushing here, or from staging. No, all of these are not possible. So what we should do, first of all, your changes should go to staging area. From staging area, you will move them to local repository. From local repository, it goes to remote. This is called the Git tree or the Git architecture. That's how your changes moves to remote. And another important thing, until you move your changes to remote, no one else in your team can see your changes. Because like I said, this is my workstation, my local computer. So as long as they were in the local repository, they were here, it is in my local computer. Only once you move to remote, others can see your changes, right? So working directory, staging area, and local repository. This is the terminology. Now you might be having a question. What is the importance of this index area? Why should we have this? Why should we push to staging area or index area, right? It is because this staging area works like a preview or else a pre-check before your changes goes to local. Right? It's like a dry run or else kind of pre-check before your changes goes to local. Let me give another example. Suppose there are 10 files in working directory. Out of this, I want only 5 files to go to local. You will add only those 5 files to staging area, right? We will see more about this in few minutes. Today, we are going to get started with the lab. I'll show you each and every component there and I'll justify what we were discussing now, right? We will practically see what we were talking about. So first, let me explain theoretically and I'm going to show you with a hands-on. Yes, Anyone has any question?
Yeah, Preethi, this is Sachin.
Yeah, hi,
Can you
Sachin.
hear me?
Yes, go ahead.
Yeah. I think, thanks for that. So far I'm clear. Only I have a doubt on working directory and local repository. Correct me if I am wrong. And in the remote repository, all the folder will be available in the local repository. Whatever changes we do, those files we kept in the working directory, isn't it?
Correct. But let's not jump into there. I'll take you there step by step. Correct.
Okay, yeah, got it.
This is how it works. Here, let's go step by step on how local repositories, all of that are created. Before that, I would like to tell you another interesting part. Imagine these are like folders in your local computer, right? Interesting part is working directory, local repository are physically the same folder. Yes, it's a single folder. Correct. Means they overlap each other. Then how come you say working directory and local repository, isn't it? Because logically they are different. What is meant by that logically different? Let's see here. Let's imagine this is my local repository. Also my working directory. Yes, let's say this folder is called local repository. The same one is the working directory. Then how come we differentiate it? Yes, see here. Suppose you have just created a file here in this folder. Okay, you created or you brought file somewhere kept in this. It is said to be in the working directory. Okay. Then let's say after bringing this file, you have run this command, you added it to staging area. Then it is said to be in the staging area. After this, let's say you have done commits. Commands we will learn later. Okay, you have done the commit on that file. Then that is said to be in the local repository. But physically, it's in the same folder. Am I making sense? This is very interesting. I'll show you this in few minutes. In 5
Yeah, this is
minutes,
what
we
I
can.
want. Now I clear with.
Mm.
Thanks so much.
Yeah. Now we are getting into this hands-on, right? So it will be very clear for you. But yes, they are same. That's just one folder. Staging area is not at all a folder. It's a virtual layer. So imagine it's just one folder. When you just kept the file there means you will call it as a working directory. When you run git add command, it is set to be in the staging area. When you commit, then it is set to be in local. Then after committing, you may push those changes to remote so that your colleagues, your team members can see what changes you have done. So this is one thing you have to understand. See, Git is really very interesting tool. If you learn with the fundamentals, with the basics clear, you can enjoy Git, you can play with the Git. Otherwise, if any challenges comes in the real world, like you might be pushing your changes, you might have get conflicts. To resolve the conflicts, to fix the conflicts, you have to have the basic knowledge, these fundamentals very clear and strong. If you are strong with this kind of fundamentals at the back end, things like what is happening at the back end, you can clear any sort of questions in every interview and also work in your projects. So, yeah, and let me tell you another two things. There were two use cases, how local repository is created. Let's talk about how local repository is created. There are two scenarios or use cases how it can be created in the real world. One use case is, okay, let's suppose it's an old project. I joined this project as a new DevOps engineer, and now I'm asked to make some changes. So I'll copy from remote and create a local repository. That's one way. Right, and then continue working there, and then once you are done, you push the changes and pull the changes and so on. Second scenario is, okay, it's a completely new project. I joined the team as a DevOps engineer. Now there's nothing on remote because it's a new project. I have to create an empty local repository, then make the changes and then push to remote. So those are the two different use cases you have. And we will cover both those use cases. First, today we'll get started with the second use case. And then we will get into the first use case slowly. Are we good?
Yes.
Can we get started with the hands-on?
Yes,
Any
true.
questions here? So whatever we discussed, okay, like if we assume it's a new project, there's nothing on remote, like how to create an empty local repository, we'll see. How come working directory, local repository are same, we'll see all of these things. What is Git add, Git commit, all of them we are going to see now. Before that, one last thing, Git works on multiple operating systems. You can use it on Windows, you can use it on Mac, Linux, and so on. It supports multiple operating systems. So whatever operating system you have, you can use Git directly in your laptop. It could be Mac or Linux or Windows, any versions are fine. Let's get started using Git in our local computer, right? So
Yeah.
let us install Git first. How do we install Git? Let's see. Let's get started. You have all the download links, everything available here in the drive. If you go to Drive, you will be given access to this. For all the registered students, you might have got access to this. There is a Git folder, and here is the installation on Windows. Here, if you go, how to install it on Windows, everything is here. And then how to install it on Mac and other systems. Here is the URL. Actually, one second. This is installation on any operating system. Then installation on Windows. Okay. Installation on Windows with the screenshots as well. This is the URL. Okay. But yes, I have shared all the URLs, everything here. These URLs might be changing and all. So I would like to take you through the process. Go to Google and type in Git downloads. Right. You should be seeing this in the list and go to this gitscm.com. Here you can see different downloads, like if it is Windows, download the executable as per your specifications of your Windows, depending on either it is 62-bit or 64-bit. Download the executable and run the executable. I believe you all know how to run the executable. Still, if you need any help, here is the documentation with the screenshots. Like, okay, click on this, you get this executable like this. Double click and run the executable. You will be taken through the wizard like this. Keep continuing next and you will be proceeded this way, right? This is how Git works. I mean, that's how you install Git on Windows. If it is Linux, just go back to the downloads. You have a simple command, depending on whether it is a Debian or Ubuntu or CentOS. Here is the command. Commands are available depending on the distributions. You can just run the command. And if it is Mac again, it's a simple command, brew install Git. That's all. So that should install Git. Mine is a Mac. And one more thing, whether it is a Mac or a Linux or Windows, only installation steps differ. And all the commands remain same, almost 99.99%. All the other commands would be same. So irrespective of operating system, the concepts, commands would be similar. So you can use any of the operating system. If it is Mac, launch your terminal and run the commands. If it is Windows, after installation, okay. So if it is Mac, launch the terminal. If it is Windows, after installation, you will go to start menu and run git bash. Git bash will launch a terminal, which will having bash at the backend. So which provides a bash environment. So you can use it. So run the command git version, right? So you can see git install here. Now let us use git. So, okay, fine, Git is installed in my system, but how do we use Git? Or else, okay, Git is installed and I have some project folder on my computer. I want Git to version control that particular folder, right? So first let's get to some folder which we need to version control. On the desktop, I'm just going to create a folder called Git demo. By the way, what is this CD? Change directory. Go to this desktop, make directory mkd. These are simple command line or else Linux commands. You might be using them in your command prompt in Windows also, right? We will learn Linux commands separately. Just understand this is to navigate to a particular folder and this is to create a directory. Let's suppose if anyone here who are not comfortable with the CLI, you can also use the GUI, no worries. I just need some folder where I want to keep my project files. So this is my desktop. Just go to the desktop, right click, create a new folder. Perfect. Right? That's how you can create it. Or else you can use this GUI. So let's assume this is a new project. Okay, it's a new project. There's nothing on remote. How do you create in that case? Create an empty local repository, right? I am taking up the second use case now. And also I just want to keep all my project files in a folder called Git demo. Go into this folder. So this is empty. It doesn't have anything. Now I want this to keep as my project folder. I want to make this as a local repository, right? I don't want, because it's a new project, there's nothing on remote and I want to create an empty local repository. This should be version controlled. Any files, any folders present in this Git demo should be version controlled by Git. So how to tell Git to version control this folder, and or else how to tell Git to create an empty local repository? These are the different ways you can interpret, like how to create an empty local repository because there's nothing on remote, it's a new project. Or else like how to tell Git to version control a particular folder on my computer, right? So whichever folder you want Git to version control, go to that folder. Go to that folder and run the command git init. Git init means initializing Git, starting Git, right? So let us run git init. See, it tells that initialize empty Git repository, and this is the path. This is the Git demo and .git is created. See, it's not seeing because it's a hidden file. To see the hidden file, ls-a. See, yes, I can see .git. If you are not comfortable with the CLI, like I told you, if you just want to use the GUI, it's perfect. You can do that. See, this is the folder. If you go, you can see .git, right? So yes, that's nothing but local repository. You are seeing .git means that particular folder is nothing but a local repository. How do you identify local repositories? A local repository, a folder is said to be local repository means it will have .git. That's one first thing. Second thing is any files present here will be version controlled by Git. How do you know? Let's see. Now there were no files. I'll create some file. Again, how to create a file? Go to the GUI, right click, create a new file. That way you can create, or else I'm creating from the CLI using touch command. Touch command will help you create a file. You can create any file. If you are coming from development background, create some program files. If you are a tester, create any text files, scripts, anything is fine. A JavaScript or a C# or a C++, whatever, or else simple shell script or a Python script, or else any dummy text files are also fine. Because here our interest is not to learn the content of the files or anything here. Here our focus is to version control the file. So to version control the file, it could be anything. So I'm just creating simple text file. Later on, we will apply the same for our Terraform config files, Kubernetes manifest files, Ansible playbooks and all. For now, dummy file, but the same concept would be applied irrespective of the file type and the nature of the file. So yes, I have created a file. Is Git is tracking it or not? How do you know? Git status. Git status is another basic command which will tell you whether it is being version controlled by Git or not. So if you see Git status, you will see file 1 and you will see it as untracked. Means Git knows there is a file, but it is saying it is untracked. It's not tracking it and it is asking us to git add to track. Now, the most important thing is you have to identify like where is this file with respect to the version control system? Where is this file? Where is this file in the sense whether it is in the working directory or staging area or local repository? Always refer to this diagram and you can answer it.
Working directory.
Working directory.
Because it is asking us to add the changes, right? It's asking us to add, means it is in the working directory. And that's what I was quoting some time back, right? I was talking about, like you just kept the file there, means it is set to be in the working directory, right? I just created a file. So it's in the working directory. So what I should do, if it is in the working directory, this first part, this one, I'm talking about this, just created a file, it's in the working directory. Correct? So now
Yes.
what should we do? For it to get
Git add.
that, git add file name. Now can you tell me where is the file? Let's see the status.
Staging.
Yeah, if you have any doubt, status will tell you. Changes to be committed. To be committed means where is it? Where is
Staging area.
Always keep this architectural diagram in your mind. It is asking me to commit, means where is that file? From where you can commit? From the staging area, right? So now what do? Git commit -a, okay, -m. M flag is mandatory. That's a message. So you can give some message relevant to what changes you are doing. Let's suppose, okay, this is about some first change or whatever, first file kind of. Okay, message is mandate. It is committed. Okay, once it is committed, if you see status, it tells you it's clean. Clean means whatever changes are there in your working directory staging area were all moved to your local repository. It's a committed, right? And then ls will show the list of the files. ls -a will show all the files, including the hidden files like .git, and git ls files will show the files either in the staging area or local repository. Now, yes, it's in the local repository. Got this point, everyone? Is this much clear for all of you? Understood? Are we good?
Yeah, really good.
Right?
Thanks, Preethi.
Yeah, let us do the same exercise with another file so that any more blurriness you have, that should be clarified. Right? Let us repeat this with another file. Let me create one more file. I'm just creating some dummy file for our learning. Now, if I do ls, yes, two files are there. Can you tell me where is this file to? Whether it is in the working directory or staging area or local repository?
Working directory.
How do we know?
So Git status.
Git state. Again, untracked. Untracked means, okay, it's a new file. Git know there is a file, but Git is not tracking it. It is asking us to add so that we can track it. Right? So this is one thing. Another thing is Git ls files. See, it's not showing you file 2 because file 2 is not in the staging area as well as the local repository. Correct? Understood?
Yeah.
Is this much clear now? It should be very clear. File 2 is no more, but in ls, yes, you have file 2. This is how you can identify which files are in the staging area, which files are in the working directory. Or else status command will also tell you. Okay, fine. Now, the file is in the working directory. I want to move to staging area. What is the command?
Git add.
Always refer this diagram. So we should do git add. Simple command, git add file name, git add file to, done. Check the status. See, it says changes to be committed. Also git ls files. Yes, now you are seeing file 2 because it is added to the staging area. Right? So now what you can do? Git commit. It's asking me to commit. So -m, let's say second file, done. Now, already it's there in the git ls because after adding staging area. Now git status, working trace. Got the concept? Whatever we have discussed here theoretically, I have shown you everything. Any questions from anyone? This is what? Logically same, right? Sorry, logically different, physically same. Yes, this git demo is nothing but your working directory. This git demo is nothing but your local repository. So it's just one and the same. Is that making sense now? Right?
Yeah, I'm right now I'm clear with it. Yeah.
Yeah. So it is same, but logically, this is how it's different. When the file is created, we say it's in the working directory. When it is moved to staging area, like we do git add to move to staging area and git commit to move to local. And we created an empty local repository using git init so that that particular project becomes local repository. Any files, any content available there is being version controlled by Git. Right.
Yeah,
So,
Preethi, one doubt actually. Can we create a project name? Under that, can we put the different folder
yes, you
instead
can.
of
Yes, you
yeah,
can like
okay.
we version control files the same way. Git add that folder name. So whatever
Yeah,
content in that folder will be added recursively. Same way, how do
okay.
you deal with files? You can deal with the folders. This can be some project name, like your project name, fcap, something like that, and then you put
Yeah, under the
subfolder,
video subdirectory. Yeah, correct,
multiple
correct.
things. And yeah.
Thank you.
Now, let me show you one more thing. Till now, we are making some changes, right? Like we made some commits. And by the way, remember, this is all in my local computer. I did not share it with others. We did not go to remote it. Okay. The thing is, before going to remote, we have to learn many things over here. We did not go to remote it. We will go to remote. Okay. We have to learn many things on local before we go to remote. So these changes are confined for myself. Okay. And now, I have made some commits, right? If you want to see, like whenever you make a commit ID means whenever you run a commit command, a commit ID will be generated. That's alphanumeric unique code. And this commit history will be stored, and you can see that with the git log. See here, every commit ID will be generating this hash code alphanumeric ID, which is unique, commit message, author, like who made the changes, including the timestamp. How is it grepping them? For the first time of running this, it will means for the first time, let's say if I'm running this for the first time, it will prompt for username and the email ID. Because it's not for me first time on this computer, it doesn't prompt me. Then you have to run these commands. Git config user.name and some name. And then another command. I canceled it actually. And then git config user.email and the email ID. These commands you have to run. I have canceled it. Then like it will register with that name and the email ID. Right? And the timestamp, like we were talking about, right? It will create a log including the person who made the changes with the timestamp, like on November 11, 6:47, commit message, everything, right? So that's the importance of log. It will show you the commit history, and that's how you can see the commit history. Okay. And then another thing is commit message is very important because at a later point of time, after 10 days, if I see, I should see a meaningful message. You should provide a meaningful message rather than a first file, second file. Like suppose I'm making some changes relevant to EC2 instance. So I will put that in the comment so that after 10 days, when I refer it, okay, I should understand, okay, these changes are related to these messages. Understood? So that's how you
Yes,
have
Preethi,
the
yes.
commit history. And if you just want to see a brief log, not the detailed log, git log one line. That will show you just a simple brief log instead of the detailed log. First 6 characters of the commit are enough, and then the commit message. If you want to know what changes happened in that commit, git show, copy those 6 commits, 6 characters. See, you will see, okay, this file is changed. Of course, because we did not make any changes, it's not showing. I did not add any content to the file. So that's how it shows. If you have added any lines removed or modified will be shown here. Okay. So that's about the log command. Till now, we have made 2 files. We have made 2 commits. So let us proceed and make few more changes. Good to go. Can I get confirmation from everyone? Appreciate your quick responses. Are you all with me? Good to go?
Yeah, with you. Yeah, good to go. Thank you.
Right. Right. So till now we have created new files, right? Like file 1, file 2, but need not be necessarily always new file. It might be modifying an existing file, isn't it? It need not be like always you create a file. So you may also modify the file. So let us see that. See, you can modify the file in multiple ways. If you are like I told you, if you are comfortable with the CLI, sorry, with the GUI, you may just go here, open the file this way. Okay, make some changes, save this. Okay, that's how you can do the changes. Or else you can use any editors like VI editors, Vim editors of your choice. I just want to edit the file at this point. I have made some changes to file 1. Let's see what it has to say. See, do you see that? Remember one thing,
Yes.
Git works with respect to changes. What is meant by change? In Git terminology, in Git language, change could be creating a file. Change could be modifying a file. Or change could be deleting a file. It could be anything. Git works with respect to changes, and any change will follow the same process. Any change made will be there in the first, where will be your modifications?
Local.
Not staged. Not staged means where are those changes? Not staged.
Working directory.
Not staged means yes, it's not staged means it's the working directory. It's giving you the clue. Git add to update the file. So what you should do, git add, again the file name. Now if you do status, see here, changes to be committed. To be committed means where are the changes?
Staging area.
Yes, everyone, can I hear from everyone? Right, changes, I have committed. Changes are in the staging area. It's asking me to commit the changes. Then go push the changes to local repository. Git commit minus AM file modified. Done. Right?
What is the difference, madam? Minus M, minus AM?
Just ignore minus AM, just minus M. It's minus M. I'll tell you. Okay. So this is how you have modified. I'm modifying changes again. I'm modifying the same file again. I'm using VI editor. If you are not comfortable, use the from GUI. VI editor also I'll teach you once we start Linux. Anyway, I made some changes. Now, status. See here again, changes not staged. So changes not staged means,
Working directory.
so
Git add.
you might have seen some time back. Earlier we have seen untracked or unstaged. Both are in the working directory, right? But what is the difference between untracked and unstaged changes? Did you notice any difference?
Yeah, untracked means new file. Unstaged means modified file.
Modified.
Correct.
First
Untracked
modified.
will be for the new file. For the first time, it will be showing like this. Unstaged means it's just modification. File is already there in staging area. Certain modifications are not there. Then it will show you unstaged. You need to have this clarity whenever you see this message. Right? So for untracked file, what you will do? You will add and then you will do git commit. That's how you should do. For unstaged, yes, you can do git add and then you can do git commit separately. Or else, because it's not a new file, you could also do this way. Minus AM, add and commit with a single line because it's a unstaged. It's not new. Right? That is the difference. Understood the difference, everyone? For untracked, you have to do this separately. Whereas for unstaged, you can do separately as well as you can also do this way. Some time back we did the separately, right? Now let us do it in a single command. Okay, I will not do git add and commit. Rather, I'll commit with add and commit. A flag. File again modified. Are we good?
Yes.
Right. So changes are added and committed. And If you see the status, yes, it's clean. It's a working tree is clean. Right? So this is how you can do any modifications, and that's the difference between untracked and unstaged changes. Untracked is for the first time, it's a new file, you do it. For unstaged, this is how you can do it. All right? And another thing is any command, let's suppose it's a git log or git commit, whatever. There were so many flags or options available. It's not necessary that you by heart all those flags, all those options. What I mean is, okay, I have shown git log one line, right? There were so many other options. Let's say you want to see log of a particular date, between particular dates, you want to see the logs, or you want to see the log of a particular user kind of. You have so many options. To see that, run the command with the help. See, it will open this man page, right? Git log, explanation, description of what it does, and so many options. See, follow, no decorate, decorate. You don't need to see so many options. It's not that you will by heart, you will learn all of them. No one knows all of them. No one will by heart. That's not how, that's not the expectation from this. The expectation is any requirement you have, you should know, okay, using this help, I can explore. You should be habituated user to this kind of exploration. That's the expectation. It's not that you by heart and memorize all of them, right? Out of which we are using online. So that's how you can check the man pages, or else you can check this way also. Here also, you can just go here and go to the documentation. This is for your reference. Okay, this official website is very good for your reference. You can use it. Like you want to check on log. The same man pages can be verified here as well. Okay, git log documentation. Synopsis, whatever we have seen there, you can also see here. Right? So this is for your reference. Even those references, installation guides, even the presentation I'm using, including the architectural diagram, everything was placed in this Google Drive, which you can access and use it for your learning. Git references, additional references for Git, right? These are the repositories we'll be working on, cheat sheet, everything there. Okay, here at this point, I just want to show you one more thing. Till now, if you want to modify any file, what are we doing? We are just opening the file, right? Or else we are opening using Vim editor and all. There is another editor. Like you all know what is an editor, right? Like your Notepad plus plus, or else a Word document. These are all the editors where you can modify the files, isn't it? Similarly, we can use some better editors to modify our files. Also, we will use the same editor to modify our Kubernetes configuration files and all, which is VS Code editor. So better you can start using it even to modify some text files also. So just go to Google and type in VS Code editor download. Right here it is available for again for all the operating systems. And here are the downloads. If it is Windows, just download and launch it. That's all. You don't need to install. Download that and double click to launch it. Same is the case with Mac and all. Even this link is available here. VS Code download. So it's very simple to install. Just understand it's another editor. Don't get confused by seeing this one. Are you doing coding and all? No, anyone can use it. Even text files can be edited. So this is the VS Code editor. Once you launch it, you will have a view like this. Now I can open my folder here. Go to file, open folder. My folder, my project folder is this Git demo, right? See, you can see a better view of your files and folders here. So now how do you run the commands? I'm using terminal in Mac, right? I'm using this terminal. If it is Windows, you are using Git bash. Instead of launching another terminal, here itself you can launch your terminal. Am I making sense? Just go here, launch the new terminal. Here itself you can have your terminal. Like whatever commands you are running there, you can run here. It's very easy to visualize all of them in this. It's showing clean means everything is in place. All the changes were in place. Also, if you want to edit any file, click the file. And this is how we have added some lines some time back using a notepad, right? This is how you can edit. Okay, let me make a modification to this file one again, just to show you the VS Code editor. I just added something, save it. Once you make some changes, save it. Now, do you see here, this is another advantage. If you keep the cursor, it tells that it's modified. Of course, you can also get that with the status. Changes not staged, obviously. What you should do? Git add and commit, or else git commit -am file again modified. Something like this. Now, you see, you don't see any marker there. It means that the file is added to local repository. If you see git status, typo, git status, it's clean. Right? That's how you can get started using this editor. So you have to install Git, you have to install VS Code editor, which is not mandatory, but very good to have. So install Git, install VS Code editor, create some folder and start version controlling your files and folders. Any questions from anyone? And another important thing is, so if you see here, whenever you make a commit, you run a commit command, whatever files and folders present in the staging area were all committed. Means whenever you run commit command, any number of files present in the staging area, all of them will be committed. But what if you want to commit only a particular file? Right, that also you can do using git commit file name. Like this is the command. Let me add the command here. Git commit file one and then the message. That's the command. If you want to commit only a specific file. And git add file name will add that specific file, right? Suppose you want to add all the files present in the working directory. Git add dot. Dot means it will add whatever present in the working directory. These are some miscellaneous commands to add multiple files or to commit a specific file. If you don't put this file name, whatever in the staging area will be committed. Right? Those are some basic differences. Can I go to the next scenario if you're all clear with this?
Yes, ma'am.
All right, let us take up another file. I'm just creating one more. This is how you create a file. You can click on this plus and create a file. I'm just creating a text file, adding some line like this. Okay, done. Save it. Do you see here? You keep the cursor. It tells you it's untracked, right? That's a benefit of version control system. It will tell you the status of the file. Of course, if you see here also, yes, it's untracked. Okay, fine. I want to commit this file. What should I do?
Git add.
Git add. Can I do git commit -am at this point?
No.
We can't do that because it's a new file, right? You have to do it separately only. See git status. And also here, if you keep the cursor, it tells you that the file is index added to staging area. Now git commit -am. Anyway, I have only one file. So let's say third file. Okay, done. Now, if I do git status, it tells you it's a clean, right? So all the files were added here. Now, let's suppose, okay, I want to further modify this file. We did this actually before also, but now I just made some change. Now, can you tell me where is this change? Where is this modification?
Local directory.
Working directory, right? It's in the working
directory.
directory. It's an unstaged change. And if you want to see unstaged changes of any file, git diff file name will show you unstaged changes of the file. See here, actually, This is the line added, right? This is the line added. So these were all like unstaged. I mean, the new line which is added is unstaged. That's what it's showing. Right? Unstaged changes can be seen this way. Git status. See, not a stage means it's having unstaged. Unstaged changes can be seen this way. Okay, fine. I would like to add it. Let me add this. Now, is this file having any unstaged changes?
No.
No, right? So if you do git add, see, no output because it's not having any unstaged changes. But is it having staged changes or not?
No.
It is having staged changes, right? Just now we staged it into the staging area. The second line is a staged change, isn't it? Okay, let's see the status.
Yeah.
The changes to be committed means it's having staged changes. So to see the staged changes, git diff staged. See, that will show you the test staged changes because yes, we just made some changes, staged it to the staging area, and that's how you can see. Right? Again, if you want, you can commit and all. These are the other two commands, like git diff file name to see unstaged changes, git diff staged flag to see the staged changes. Any questions from anyone?
Yeah, no, madam. I think staged, the unstaged and all, if it is a big file, are we using this practical, madam, these two commands?
Just to see, just to know whether there are staged changes and all, we can use it. Whether there were any
Great.
changes or not.
Okay.
And so these are the commands we have used today. Let me summarize our learning today. We have started installing it and then git init, which will create a local repository, and then git add, git commit -m, so that you will send the commit message to make the commits, right? And then we did git commit, git add, and then git log, right? Also to see a simple log, git log offline, so that it will show you just simple log. And on any command, if you want to see the help text or else the git manual, git man pages, help command will help you, right? Also, let's say to see the changes, git status always, and git ls files to see the files in the staging area and local repository, right? And then git status we did, yeah, and for unstaged changes, git commit -am if it is unstaged. If it is untracked, we should use only git add, git commit separately, right? Also, to see the unstaged changes, git diff file name, and then to see the staged changes, git diff staged file name, right? So these are the commands we have learned today. Very simple commands and the basic commands. And how do you get started with your hands-on today? First, you have the recording will be available in some time. So go through the recording and go to our website where you have all of these assignments documented. Go to lab exercises, Git lab assignments, where you have everything like how do you install Git, how do you configure Git, how do you create a sample project. And if you go to assignment, these are the topics. And here are the step-by-step commands like git init, okay, git status, git add, all the commands with explanations are available here, right? This is how you should do the hands-on. Topics are listed here and the assignment is here and the quiz for today is also available here. I believe the first quiz is available for everyone. You can access it. I'm also sharing it in the Zoom chat so that you can get started taking up the quiz. It will be for your understanding, like for checking how much you understood. And like if you have gone wrong somewhere, you can retake the quiz. Have you all got the quiz? Can you all access it? I have shared the link in the Zoom chat. Click that and see if you all can access it.
Yes.
So go through it, and if, you can also submit it and you will see the right answers. A simple quiz for day 1 of Git. You can validate and retake the quiz after watching the recording. If you have gone anywhere wrong or any questions you have, you can ask. So that is all for today. We'll continue from here in the next day. But if you have any questions or anything, you can feel free to go ahead. The same process will continue from day 1 till the last day. This is a basic part of Git we have covered. Tomorrow we'll deep dive into the next concepts like deleting the files, reset, rebase, revert. All of these concepts are coming up tomorrow. In the same link, Algar, like whatever shared in the community, there is a YouTube link shared yesterday, right? On the same link, it's a playlist. So all the videos will be added to the same playlist. You can see the same there. And then do the hands-on, set up your Git before you join the next class. Definitely hands-on is mandatory. You should do hands-on on daily basis, regularly after the class. So complete the hands-on till this much before you join the next class. Any more questions from anyone?
Yeah, yes, Preethi, I have one question.
Yes, please.
Yeah. Say for example, we have file one, okay. So two users are working in the same time, file one, okay. The same time pushing user one and user two, what it will happen?
It will not override, it will not ignore. Okay, it will tell you in the form of conflict. We are going to cover those scenarios, Venkat, for your information. Like I have shown you the differences between working directory, local repository. In the same level of clarity, we will also cover these scenarios. Those scenarios are all coming up. It will not, like we discussed scenario today, right? It will not ignore or it will not override. Rather, it will tell you in the form of conflict. We will resolve the conflict and fix it. So how that actually happens, how do we get changes from others? How do we get conflict within our own local repos? How do we get conflict on remotes? We are having all those scenarios. We'll cover them.
Okay.
What is meant by conflict? When does these conflicts happen? How to resolve? Separate topic is there. We'll cover all of that. I think it is on day 3. Conflicts are covered on day 3.
Okay.
Yeah. Project to practice. Okay, it needs access. Project to practice resolving Git conflicts. Here are those scenarios covered. Any more questions from anyone? So get started with your hands-on and we'll continue from here. Yes, please tell me.
This Sachin, I don't have access of Google. Can you
Sorry?
please check it? On that Google Drive documents, no, I'm not able to see in the Google Drive.
Yeah, all the registered students will get access. If you have registered or to register yourself, you can contact Mr. Raj on this number. His number is on the website. You can contact him for the details.
Okay.
Here is the number on the website.
Okay, good.
Here it is.
Right.
All right, then any further queries or anything you have, you can reach out on this number on Mr. Raj. He can help you with all the further details. Thank you all.
Okay. Thank you.
Have a good day. Bye, everyone.
Thank you. Thank you. Have a great day.
Have a good day. Thank you.